Welcome to the next session. I'm going to quickly start us this moment with the example. So I'm going to start with example 2.1. I'm going to quickly. Example 2.1 deals with a star delta system. That is star. When they say star delta, that means the supply is star. This is the supply is star, and delta, that is the load, is connected in delta. That is what they mean by star delta. So you connect A to A, B to B, and C to C. Right. So this will be ZAB, this will be ZBC, and this will be ZCA. Right. So now, if you want to solve this problem, there we are asked to. They said in a three-phase star delta system, the load impedances are 16 at angle 36 degree ohms, 19 at angle minus 21 degrees ohms, and 26 at angle 54 degrees ohms in phases A, B, C, in this A, B, B, C, and C, A. They say VA is given as 240 at angle 0. So when they give you the VA, which means it is the line voltage. Sorry, it is the phase voltage. And let's not forget the phasor diagram that we are drawing deals only with the source. We are dealing with the source, not the load. So we are drawing the phasor diagram of the supply voltage. So VA is given, that is the phase voltage. VA is given at 240 at angle 0 degree. So they say VA is at angle 0 degree. That is the reference, which is 240 degrees. That is 240 at angle 0 degree. That is the voltage, reference voltage. So now use a negative phase sequence and calculate the line current drawn from the supply. Draw a phasor diagram of the line and phase current. They say use a negative phase sequence. A negative phase sequence, if it is positive phase sequence, the next one here will be VB. But because it is negative phase sequence, it is not going to be VA, VB, VC. It will be VA, VB, VC. You get it? If it is positive phase sequence, it will be VA, VB, VC. But if it is negative phase sequence, it will be VA, VB, VC. Right. Now, then we if this is, and because we said our negative phase sequence, if it's a negative phase sequence, we said the line voltage will always lag the phase voltage by 30 degrees. So this is VA, VAB at angle minus 30 degrees because it is negative phase sequence. So this also, if this is at angle 120 degrees, so by 30 degrees, this will be what? VBC at angle 90 degrees, right? Then this also, this is at angle minus 120 degrees. So our VCA will be at angle minus 150 degrees. That is our phasor diagram represented there. Now we are asked to calculate the line current drawn from the supply. Line current, these are line currents from the supply. IA is the line current. IB, these are the line currents. These are IC. These are the line currents that are drawn from the supply. So to calculate IA, our IA will be what? Will be, if you look at this, this is our IA is going into these 2 points. It's divided into these 2 points, IA. So that means our IA, and if you use Kirchhoff's current law, you look at all the currents, the summation of all the currents approaching and leaving this node. IA is going to the node. We can take it as positive. The one going into it as positive. The one going away, IAB, as going away. ICA as going into it. So IAB, ICA also going into the node. We take it as positive. And IAB moving away minus IAB is equal to 0. Summation is equal to 0 according to Kirchhoff's current law. Right. So then, if that be the case, our IA then will be what? Will be IAB minus ICA. So that is our IA is equal to IAB minus ICA. So we now need to find what is our IAB and what is our ICA. So our IAB our IAB is equal to voltage across this divided by this impedance. The voltage across AB divided by the impedance. So our IAB is VAB divided by ZAB. And what is our VAB? Our VAB is at angle minus 30 from the phasor diagram. So now let's look at it somewhere. The VA is 240. VAB is different from VA. VA is 240. VA is phase voltage. VAB is line voltage. What is the relationship between phase voltage and line voltage? Our phase voltage, our line voltage is √3 times phase voltage. Right. Let's not forget that we are working here on the supply. The phasor diagram is for the supply. So our line voltage is equal to √3 times V phase. So, and this is phase voltage, which is 240. So our VAB then will be what? Our VAB will then be, which is the line voltage. Our line voltage, which is our VAB, will be √3 times phase voltage, which is 240. Right. So our VAB is 240 √3 times 240 at angle what? Minus 30 degrees. Divided by our ZAB. What is our ZAB from the question? Our ZAB is given as 16 at angle 36. 16 at angle 36 degrees. So when you calculate that one out, you'll find our IAB to be equal to what? 25.981 at angle minus 66 degrees amps. Then that means we have determined our IAB. We now need our ICA. Let's not forget that we said that let's not forget that we said our IA, and we found IA plus ICA minus IAB to be equal to 0, and we concluded that our IA is equal to IAB minus ICA. So we have found our IAB now. So we need our ICA. Our ICA will now give us what? Our ICA is equal to VCA by ZCA. What is our VCA? Our VCA is here, which is also line voltage. Because it's line voltage, you multiply with √3 to give you that line voltage. That is √3 times 240 at angle minus 150 degrees divided by the impedance ZCA, which is 26 at angle 54. 26 at angle 54 degrees. And what does that give you? Our ICA will give you 15.988 at angle 156 degrees. Right. So you do the same thing for your Then after finding this, you can now subtract ICA from IAB that you calculated, and you get what your IA is. Then that gives you this current IA. Then when you come to IB also, you find IA. Now when you come to IB, you do the same thing. Your IB, which is this current, you look at the current and look at this node and take the summation of all this current going into and coming out of the node. So IB is assumed to be going in, which is positive. So IB positive plus which one is going in? IAB is going to the node also, plus IAB, and IBC is moving away from the node, because this is IBC is moving away from the node. IBC is moving away from the node. So IAB is coming in, IB is going to the, so IAB minus IBC using Kirchhoff's current law is equal to 0. So that means our IB is equal to what? IBC minus IAB. So our IBC will be VBC over ZBC minus VAB over ZAB. And you know what your VBC? Your VBC is this one, which is at angle 90. But don't forget that it is line voltage, so you must multiply the phase voltage that is given as reference by root 3. So that means it will be root 3 times 240, right, at angle 90 degrees divided by the ZBC given in the question, which is 19 at angle minus 21, 19 at angle minus 21 degrees. So you use that to get your V, to get your IBC, and you already found your IAB before when we are calculating our IA. So you can just subtract from it and you get your IB, and you do the same thing for IC. Then after you have done that, you can then plot it on the line. All the currents, you can just plot it, the magnitude and the angle on the line. That is example 2.1. If there's any problem in getting to understand it, you let me know. Thank you.